All right, today we are pulling back the curtain on a classic digital heist. We're not just going to learn about some vulnerability, we're actually going to walk through the attacker's playbook for something called cross-site request forgery, or CSRF for short. So yeah, let's dive right in.
Okay, so let's just start with the question that gets right to the heart of this whole thing. Can a hacker perform actions as you? Transfer your money, change your email, maybe even delete your account, all without ever getting their hands on your password? The answer, surprisingly, is a big, resounding yes. And today, we're going to see exactly how they pull it off.
Every good heist starts with understanding the target. So for us, that means we need to get a crystal clear picture of the vulnerability itself. So what exactly is this CSRF thing we're talking about?
At its core, cross-site request forgery is an attack that tricks your browser into making a request to a website that you're already logged into, a request you never wanted to make. The key thing to understand here is that the attack isn't targeting you directly. It's targeting the trust that a website has in your browser.
And this is the part that really blows people's minds. To pull this off, all an attacker needs is for you to be logged into a target site like your bank. But here's the kicker. They don't need your password. They don't need your username. They don't need any of your credentials. They're basically just piggybacking on the trust that's already been established between you and the website.
So how does this even work? Well, it all comes down to the way our browsers handle sessions. When you log in somewhere, the site gives your browser a little something called a session cookie. Think of it like a digital valet key. From that point on, your browser, just trying to be helpful, attaches that key to every single request it sends back to that site. The server sees the key, recognizes it, and just says, "Yep, looks good, this is a legitimate user," and lets the request through. No more questions asked.
Okay, so we get the basic idea now. Let's move on and see how this all comes together in a real attack. We're about to open up the blueprint and look at the step-by-step mechanics of a classic CSRF heist.
So here's the play-by-play. Step 1. You log into your bank. Your browser gets that session cookie. A little while later, maybe you're browsing the web and you click on a link to some other website, a malicious one. That site has hidden code that secretly tells your browser to send a request back to your bank. Let's say a request to transfer money. Your browser, just doing its job, helpfully attaches your banking session cookie to that request. And the bank's server, it sees a request come in with a valid cookie, so it processes it. Just like that. The heist is complete, and you probably never even knew it happened.
Now let's get a look at what this malicious code actually looks like. So imagine a website has a really simple and vulnerable way to change your email address. Well, the attacker's trap is just a hidden form on their own website. It's pre-filled to change the email to theirs, and a tiny little piece of JavaScript automatically submits this form the very second you land on the page. It's totally silent, completely invisible, and just devastatingly effective.
And believe it or not, it can be even simpler than that. If a website insecurely uses a simple link, what we call a GET request, for a really sensitive action, like, say, deleting your account, an attacker can trigger it just by embedding that link as the source of a hidden, one-pixel invisible image on their web page. Your browser tries to load the image, and in the process, it accidentally deletes your account. It's crazy.
Now, this isn't just some theoretical blueprint. CSRF has been used in some major digital heists over the years, so let's take a look at the real-world impact, the score, from some of these attacks.
I mean, even the absolute giants of the tech world have been hit by this. Security researchers have found CSRF vulnerabilities in pretty much every major platform you can think of. On Facebook, it could be used to make you like pages or follow people you never intended to. In PayPal, it could change your account info. On Shopify, it could lead to entire store takeovers. It just goes to show you how widespread this type of vulnerability really is.
But it's not just about websites like Facebook or PayPal. Actually, one of the most widespread and impactful uses of this attack hits a little closer to home. I'm talking about your home router.
And this is where the impact becomes incredibly clear, right? We've seen banking Trojans use CSRF to transfer funds without a user ever knowing. Historically, Gmail had a bug where an attacker could use this to set up filters that just forwarded all of your email directly to them. And with home routers, attackers could use CSRF to change your DNS settings, basically redirecting all of your internet traffic through their own malicious servers to steal your information.
Okay, that's enough about the attack. It's a little scary. How do we stop it? It's time to flip the script and look at the counter heist, the security measures that developers can use to build some really strong defenses.
Thankfully, we have a really powerful arsenal of defensive techniques. Now, the most important ones are things called CSRF tokens and same-site cookies. But there are other layers too, like checking the request headers, re-authenticating users for super-sensitive actions, and, as we talked about, never using simple GET requests for actions that change things.
The number one, absolute best defense is something called a CSRF token. So here's the idea. For your specific session, the server generates this unique, secret, totally unpredictable token, and it embeds it as a hidden value inside its forms. So when you legitimately submit a form, like to change your email, that secret token gets sent back with it. The server then checks, hey, does this request have the secret token I gave this user? Since the attacker's malicious site has no way of seeing or guessing that token, any forged request they send won't have it and the server just rejects it flat out. It's kind of like adding a secret one-time password to every important action you take.
Another really powerful modern defense is the same-site cookie attribute. And this is a protection that's built right into your browser. By setting a cookie's flag to strict, a developer is basically telling the browser, hey, never send this cookie with requests that come from other websites. This just shuts down the attack completely. The lax setting is also great. It's a good balance. It still blocks the cookie on those hidden, sneaky requests from our attack form, but it allows it when you're actively clicking a link to navigate to the site. Just this one setting can neutralize a huge number of CSRF attacks.
So, we've seen the playbook, we've seen the score, and we've seen the counter heist. Now it's time for the debrief. Let's turn you from a learner into a hunter by showing you how security pros actually go about testing for this exact vulnerability.
Here's a super simple way to do your first hunt. You log into a web application and use a tool to capture a request for an important action, like changing your profile info. Then you simply try removing that CSRF token from the request. And you just send it again. If the change still goes through, well, you found a vulnerability. It's a direct, effective test of the application's defenses.
So what's the one big thing to take away from all of this? It's this mental model. From now on, whenever you look at a website's features, I want you to ask yourself this one simple question. Can I trick a logged-in user's browser into making this request? If the answer is yes, you might just be looking at the start of your very own CSRF heist.